A dead space station, still in orbit.
In February 1985, the Soviet space station Salyut 7 stopped responding to signals from Earth. There were no emergency messages. No malfunctions had been reported beforehand. One day, the station simply stopped transmitting. For months, flight controllers tried to re-establish communication. They sent commands. They tried alternative frequencies. Nothing worked. For months, flight controllers tried to re-establish communication. They sent commands. They tried alternative frequencies. Nothing worked. Salyut 7 had been launched on April 19, 1982, from the Baikonur Cosmodrome on a 3-stage Proton rocket. It was the 8th space station launched by the Soviet Union and the last of the Salyut program, the project that preceded the famous Mir station. With a mass of nearly 20 tons and a length of approximately 16 meters, Salyut 7 was the most advanced and comfortable station of the Salyut series. It had 2 docking ports, 3 solar panels, a refrigerator, constant hot water, and an interior designed to be more habitable than its predecessors. It had received multiple crews since 1982 and had been used for scientific research, astronomical observations, and military experiments. But at that moment, the station was empty. There were no cosmonauts on board. The automatic systems kept the station operational in the absence of a crew. Or at least, that was supposed to happen. When communication was lost on February 11th, 1985, the controllers at the flight center in Kaliningrad, east of Moscow, did not understand what had happened. There were no signs of impact, no indications of an explosion or catastrophic failure. The station had simply shut down. The silence was total. The problem was not just technical, it was political. We were in the middle of the Cold War. The Soviet Union had invested enormous resources in its space program to demonstrate its technological superiority over the United States. A dead space station, drifting, was a failure they could not afford. The United States was operating its Space Shuttle Challenger with great success. The Soviet Union could not show weakness. Furthermore, there was the risk that the station could fall uncontrollably over some inhabited territory. Or worse, that the Americans might try to intercept it and seize Soviet technology. The decision was clear, but extremely difficult. They had to send a rescue mission, even though many considered it a suicide mission. For this mission, 2 of the best cosmonauts in the Soviet space program were chosen. Commander Vladimir Janabekov was one of the most experienced pilots. He had flown on multiple missions and was one of the few cosmonauts who had successfully performed manual dockings. In fact, he was one of only 3 cosmonauts in the entire Soviet Union with manual docking experience in orbit. He was born in 1942 in Uzbekistan and had taken his wife's surname to honor her ancestors, an unusual gesture in the Soviet Union. He was a natural pilot, disciplined, but also capable of improvising when the situation required it. Flight engineer Viktor Savinik was a specialist in Salyut station systems. He knew Salyut 7 better than almost any other engineer in the program. He had participated in the design of much of the station's systems. On June 6, 1985, Soyuz T-13 launched from the Baikonur Cosmodrome with the 2 cosmonauts on board. Their mission was to dock with a dead space station. No one knew for certain if that was possible. The first major challenge was the docking. Normally, Soyuz spacecraft docked with the station using an automatic system that guided the spacecraft to the docking port. But Salyut 7 was not responding. It could not emit guidance signals. It could not stabilize itself. When the cosmonauts approached the station, they discovered that Salyut 7 was slowly rotating on its longitudinal axis. The station was rolling at a speed of approximately 1.5 degrees per second. It was not a fast rotation, but it was enough to make an automatic docking impossible. Furthermore, the station's solar panels were not oriented toward the sun. They were pointing in random directions, which meant they were not generating power. Janabekov had to perform a manual docking, without radar guidance, without communication with the station, only using a portable laser rangefinder to calculate distance and his own experience as a pilot. First, he performed a flyby inspection to make sure the exterior of the station was not damaged. He confirmed that the station's thermal panels had turned a dull gray color due to prolonged sun exposure, but that the structure was intact. Then, he had to match the station's rotation with his spacecraft, moving at the same speed in the same direction in order to fit into the docking port. It was a maneuver that no cosmonaut had attempted before, and there was no margin for error. The docking was successful. It was the first time in history that a Soyuz spacecraft had docked with a completely inactive space station. When the cosmonauts confirmed they were firmly attached to the station, there was a moment of relief at the Kaliningrad Control Center. But the real challenge was yet to come. Zhenibekov and Savinik checked the electrical connectors on the docking ring. They confirmed that Salyut 7's electrical system was completely dead. There was no power. Before opening the hatch, they took air samples from the station to make sure it was not toxic. The atmosphere inside Salyut 7 was the great mystery. No one knew if the air had become stale, if there was a buildup of carbon dioxide, or if it was breathable. When they finally opened the hatch, what they saw was an environment that looked like something out of a horror movie. Salyut 7 was completely powered down. No lights, no heating. The ventilation systems were inactive. The temperature inside was several degrees below zero. According to some sources, it reached -20 degrees Celsius or even lower. The walls and instruments were covered in frost and ice. The air was stale. Without circulation, carbon dioxide had accumulated. The cosmonauts had to put on coats and hats to endure the cold while assessing the situation. There was no drinking water. The water storage system had frozen. The life support systems were not functioning. The station was a frozen shell floating in the void. Furthermore, they discovered that 2 of the station's 8 batteries were completely useless. The rest had some residual charge, but it was very little. The first step was to find the origin of the failure. The station had multiple electrical and control systems. Something had failed, and they had failed in a chain reaction. The onboard investigation revealed that the problem began with a failure in a sensor that monitored the battery charge status. This sensor was designed to cut off the charging system when the batteries were full to prevent overcharging, but the sensor failed. At some point after radio communication was lost, the sensor on battery number 4 malfunctioned. When the system sent a charge signal once a day, the sensor interpreted that the battery was already fully charged and canceled the charge. Over time, all the batteries became completely discharged. Without power, the station's control system shut down. Without control, the solar panels stopped orienting toward the sun, ceasing to generate power. The station was left adrift, slowly freezing. But the rescue did not end there. Restoring power was just the first step. The cosmonauts had to work for days in extreme conditions to restore all of the station's systems. One of the most dangerous moments occurred when, as the station warmed up, the ice that had formed on the walls began to melt. The water that accumulated on the electrical systems and control panels caused short circuits and the risk of fire. The cosmonauts had to carefully dry the systems as the station gradually warmed. If the ice melted too quickly, the water could have permanently destroyed the electrical systems. Another challenge was the oxygen system. It was not working properly. The cosmonauts had to work in alternating shifts to avoid depleting the available oxygen. One worked while the other rested in the Soyuz, which had its own life support system. Despite all the setbacks, the mission was a success. Within 10 days, Salyut 7 was fully operational. The life support systems were working. The heating was stable. Communications with Earth had been re-established.
Janibekov and Savinik became heroes in the Soviet Union. The Soyuz T-13 mission was hailed as one of the most impressive achievements in the history of cosmonautics.
Janibekov remained on the station until September 1985, returning to Earth after 112 days in space. Savinik stayed longer, forming part of the main crew of Salyut 7 for 168 days. Later, in September 1985, another crew arrived on Soyuz T-14, and Janibekov returned to Earth with Georgy Grechko. Salyut 7 continued to operate after the rescue. In October 1985, the Cosmos 1686 module docked with the station, a heavy module containing additional experiments and equipment. In 1986, after the launch of the new Mir station, Salyut 7 was used as a transfer station. Soyuz T-15 carried cosmonauts from Mir to Salyut 7 to transfer experiments and equipment. It was the first flight between two space stations in history. Salyut 7 was last visited in June 1986. After that, it remained in uncrewed mode, orbiting Earth without a crew. But Salyut 7's story does not end there. In 1990, the station lost communication with Earth once again. This time, there was no budget for a new rescue. The Soviet Union was in its final years, facing a severe economic crisis. On February 7, 1991, Salyut 7, along with the still-attached Cosmos 1686 module, re-entered the atmosphere in an uncontrolled manner. The total mass of the complex was approximately 40 tons. Ground controllers attempted to control the re-entry trajectory so it would fall into the Atlantic Ocean, but the attempts failed. The complex disintegrated over South America, primarily over Argentina. Residents of several Argentine provinces reported seeing a huge fireball crossing the sky. Some witnesses thought it was a comet or an airplane on fire.
Fragments fell in several regions, in San Juan Province, Buenos Aires, Entre Rios, and Patagonia. Some fragments set fire to a landfill in Puerto Madryn in Chubut Province.
Several fragments were recovered and are on display in astronomy museums in Argentina. One of them, the hatch section, fell in Entre Rios province and is currently displayed at the Oro Verde Astronomical Observatory.
The rescue of Salyut 7 is still considered one of the most impressive feats in the history of space exploration. Janibekov and Savinik performed a manual docking with a dead and rotating station, worked in extreme cold conditions, and restored a space station that had been completely shut down for months. It was a demonstration that human skill and the ability to improvise can overcome even the most catastrophic failures of technology. A dead space station floating in the void, and two men who decided to bring it back.